evaluate the integral from 0 to infinity of x e to the minus x halves dx. So what we're going to do is look at this improper integral where we're going to evaluate the antiderivative between 0 and infinity. The way to do that is to take the limit as b goes to infinity of the integral from 0 to b of x e to the minus x halves dx. And now we can evaluate the integral using the fundamental theorem of calculus. So we'll find an antiderivative, plug in b and 0, and once we do that, we'll let b go to infinity and see if we get a number or not. So to get an antiderivative of x e to the minus x halves, we'll apply integration by parts, or actually, why not, we'll use the tabular method. So u will set equal to x, and dv will set equal to e to the minus x over 2. Differentiating x until we get 0 gives us x, 1, and then 0. And we integrate e to the minus x halves each corresponding time. So that gives us e to the minus x halves divided by negative 1/2, or multiplied by negative 2. And again, e to the minus x halves divided again by negative 1/2, so multiplied by another negative 2 gives us positive 4. And according to the tabular method, we multiply x downward diagonally by minus 2 e to the negative x halves with a positive sign, and then combine that with 1 multiplied diagonally with 4 e to the minus x halves with a negative sign. And that means our antiderivative is going to be negative 2x e to the minus x halves minus 4 e to the minus x halves. And of course, we're still running the limit as b goes to infinity upon us evaluating between 0 and b. But maybe we can clean this up here just a little bit first. There's a common factor of e to the minus x halves. So that's negative 2x minus 4. And instead of multiplied by e to the minus x halves, what do you say we just put that in the denominator as e to the positive x halves? Now, evaluate this between 0 and b, and still running our limit afterward will give us our result. So it'll be limit as b goes to infinity of the following expression: negative 2b minus 4 over e to the b halves minus, and we'll plug in 0, negative 2 times 0 is 0 minus 4 e to the 0 halves. Now, if we let b go to infinity, we're going to get minus infinity over infinity. But you can see with a very clear application of L'Hopital's rule that if we differentiate the top and the bottom, that we're simply going to get a minus 2 on top, and we're still going to get e to the b halves, but maybe multiplied by an extra 1/2 here. And upon letting b go to infinity, you'll see that the denominator is going to go to infinity, and the numerator is going to be stuck at negative 2. So this whole term is going to go to 0. And if that seems a little bit complicated, then what you can always do is just argue that since this is a linear term and this is an exponential term, that as b goes to infinity, that e to the b halves being an exponential term is going to go much faster, and so that's going to wipe out the numerator and make this go to 0. So then we'll get 0 minus minus plus 4 over e to the 0 halves. Well, that's just 1, so we get an answer of 4.